everybody. My name's Lee Swanwick. I'm Head of Domestic Circuit Protection for Electrium, and I'm joined by Dave Garrett, Head of Product Management for Electrium. What we wanted to do today is, for the webinar, is just have a conversation really over what we feel the considerations are when selecting a consumer unit for particular applications. But just a quick background on the company. Electrium, hopefully you guys are familiar with the brand. We've 4 major brands within the group: Crabtree, Wilex, Volex and Appleby. And we do anything within Electrium from the Appleby back box right the way through to the wiring accessories for your socket outlets and such, right the way through to single phase circuit protection, which is where myself and Dave look after that side of the business. And then we move into 3-phase with Wilex and Crabtree, and then we've got the capability of going up into molded case and custom built fabricated assemblies, etc. So hello Dave, how are you keeping today?
I'm very well, thanks Lee.
We're all enjoying this beautiful sunshine that we've got at the moment.
We certainly are.
Dave, as an electrician, back in the day, a long time ago, selecting the consumer unit was relatively simple back in my day. It tended to be a split load consumer unit, and that was it. You bought it off the shelf and you kind of cracked on with it. But now we've got quite a variation of consumer units available. So really, conversations just about how do we put the right consumer unit into the right application, and kind of what are the pros and cons about what we've got. We're seeing the 18th edition changes at the minute. That's having quite a considerable effect on the domestic circuit protection market, in particular the style of consumer units that people are using, and AFDDs is a buzzword at the minute, and certainly surge protection. So hopefully we can maybe give our opinions on what we think could be the right way to make that selection process.
Certainly the case. I mean, at the end of the day, when you look at the number of components in a consumer unit, you've got a variety of sizes of enclosure. So depending on the size of property that you're installing at, and you may start off with a smaller consumer unit, or we go up in various sizes to the largest size. And then it's really about different configurations. So as we can see here, we've got a number of options to select from the main switchboard, the top left-hand side, which has got a main switch, and it's all RCBO protection. So you've got independent circuits protected by a protective device. Then you've got other options available. We've got the split load board, for example, which has got your main switch and then some RCBOs. And then you've got an RCD, which is protecting a number of outgoing circuits, which are individually protected by an MCB. I guess probably when the 17th edition, or prior to the 17th edition coming out, that was quite a popular board. And it's probably lost its way a little bit in the last few years. But it's certainly still a very good solution as a design. We've then got the high integ and the dual RCD boards. So the bottom left-hand corner, we've got the high integ board. So you've still got some RCBO circuits on the main switch, and then you've got 2 RCDs protecting a number of outgoing circuits, each one protecting a number of outgoing circuits. Obviously, with the dual RCD solution, you've got no RCBOs. It's all about RCDs and MCBs.
And I know, as my time as a business development manager, I used to see an awful lot of the local authorities. And when the 17th edition was introduced, we did a number of presentations to people, and that was more of the use of 30 milliamp RCD protection on the majority of circuits. And it kind of got to the point in the presentation that the RCD protection was the rule rather than the exception, which was the way it previously worked. most of the local authorities that I deal with now have certainly come away from the dual RCD consumer unit, and the concern that we had with the dual RCD is as I rightly say, there's no independent circuits on there. So if you said in particular smoke detector circuit, or maybe a circuit such as say a stair lift, then you really wouldn't want any other fault on any other circuit influencing that particular circuit to switch off. So the dual RCD, I think, dare I say, it could well be a thing of the past.
I think you're right. Moving forward, I think certainly the 18th edition has tweaked a few regulations which maybe mean the designer and the electrician need to think a little bit more about those circuits and the implications of those new regulations in the 18th. We can touch on a few of those as we move on through the slides.
I think with the 17th edition, it was four main criteria really. Socket outlets needed to be 30 milliamp RCD protected. Cables in a wall or partition buried at less than 50 mil. Anything where it was a metal stub partition needed to have 30 milliamp RCD protection, or we needed to protect the cable with some sort of mechanical protection or sheath, etc. Or where any cables or circuits passed through a bathroom or shower area, they were the fundamental requirements of 30 milliamp RCDs. Is there any kind of significant changes for the 18th edition, or what we're seeing? Is there any refinement of those regulations?
Well, the main issues are, as we can see here, so we've got 41133 extends the use of 30 milliamp RCDs on sockets. It used to be up to 20 amps, and now it's moved up to 32 amps. So, all of your sockets should have RCD protection. We've also got additional RCD protection of, for example, luminaires, which were an exception previously.
Yeah.
53132 is one in particular to consider, is earth leakage. So on each individual RCD, you need to think about designing the installation such that any earth leakage is no more than 30% of the trip current. So if you've got a 30 milliamp device, then you're looking to have no more than 9 milliamps of earth leakage. And I think particularly when you've got an RCD protecting a number of outgoing circuits which are just protected by MCBs, then that's where you may struggle to design the circuit to comply with that particular regulation, and maybe that pushes you towards iInteg or a split load board, or ideally a main switchboard with all RCBO independent protection.
I think that's a key change, really, isn't it? Because you've not really got a great deal of headroom within the one RCD. So if you start to look at a dual RCD board, and we go up to, as standard, we do a 15-way dual RCD board, if you like. So that could split your circuit, say 9 on one side and 6 on the other, if my maths is correct. And so you've got quite a number of circuits that you're trying to balance across those 30 milliamp RCDs with not a great deal of headroom, really, is it? Based on that new regulation. So
exactly, and electronic equipment, things like laptops and so on, those are the things where you've got some inherent earth leakage, from those, and it's a cumulative situation. So, if you've got a family situation and everybody's, on their laptops and so on, and they're connected into the power circuit, then you might suddenly find that you're pushing the earth leakage above the 9 milliamps. So that's something that you need to think about.
I think, domestic installations, there's a lot more going on in a domestic installation in terms of what's plugged in at any one time. But I think if you start to open that up into maybe a light commercial installation where you've maybe got a number of computers or a number of laptops working in an office at one time, then previously you might have been able to put one ring main in. I imagine now it means that we need maybe more circuits, which means the consumer unit's based on this kind of layout, a high integrity layout, might well require more ways and bigger units. So we're struggling for a little bit of space there, I think, with this type of layout.
You can achieve it with high integ and split load, but you need to think about it a little bit more. Certainly, the ideal solution is to go for your main switch with individual RCBOs, because then each individual RCBO has got that 9 milliamp of earth leakage, and the chances are that you're not going to get that on just one protected circuit.
No, definitely. I think, as you'll probably, I think we're going to have a look at a summary towards the end of the presentation. But my gut feeling is I kind of know where we're going. I think we'll end up with a main switchboard with RCBOs or perhaps AFDDs. But that 9 milliamps worth of headroom, if you like, on those RCDs definitely leans it towards that selection.
Exactly so. 531.3.3. I mean, we've always been required to select the appropriate RCD, but it's the regs have been tweaked slightly just to re-emphasize the fact that you can have DC present on a circuit, and I guess that is. It's probably driven as much by electric vehicle charging as anything, but you can also get DC in things like LED drivers and USB sockets, for example, and you know, some white goods. So DC is present, and it's always been a requirement to make the appropriate choice, but it's just been re-emphasised with the 18th edition.
I think you're right. That's one of the common questions we get through the technical helpline. What's the difference between a Type AC and a Type A? And I've used the Type AC for years, and we've not had any issues with it. But again, kind of technology moves on. And just to explain briefly what the differences are, a Type AC RCD, the components in there, the coil, if you like, within that RCD, it doesn't have any tolerance to DC being imposed on the coil. So what can actually happen is it can slow down the operation or actually stop the RCD from working. It's what we call blinding. So you need to have a couple of effects all kind of happening at once, but you could have some DC leakage on that circuit. It's blinding the RCD, and then we're in an earth fault situation with the AC side of the circuit, and it stops the RCD from working. But if we move over to a Type A, what a Type A does is it has a level of tolerance which will allow us, it will see that DC leakage, it won't affect the coil, and it will still operate within the requirements for that RCD. But again, as we move through different RCDs from a Type AC to a Type A to a Type F and a Type B, what they do have is different levels of tolerance for any DC leakage on the circuit. But you're absolutely right. The point that you've made is we always need to look at what the requirements of the circuit is and select the right components for use within that circuit. So it doesn't necessarily follow that a Type A RCD, because it's got some tolerance to DC leakage, might be the right selected product. If we're going to put an EV charging unit on there, we might need to move up the criteria and go to an F or a B. But again, it's down to the installation.
Certainly is.
I mean, we're starting to see now the industry standard is becoming Type A. For the numbers that we're selling in terms of consumer, it's most of that's migrated across. But I think there's more, because that's not the misconception, if you like, but that's becoming the common product people are asking for, rather than making that selection for a Type A based on the circuit criteria. I think it's just becoming the norm to go with a Type A device.
Yeah, it's certainly become the default, but as you say, it doesn't necessarily mean it's the right solution. It may be that you need to consider a Type B, but it really depends on the installation and what's connected. And obviously a lot of if you've got a PV installation, type B is commonly specified by the PV inverter manufacturers. So you may have a demand for that type of RCD. And again, with EV chargers, most of the chargers these days have a type B built into the unit, but they may well stipulate a type A back at the consumer unit. So it's horses for courses, and you just need to stop and think about the installation and choose the appropriate RCD.
Yeah. All good fun.
Certainly is. Jumped around a little bit there, but sorry,
Dave, go on. Sorry.
This really was picking up on maybe the dual RCD board, and we hinted at earlier around about the fact that you've got one RCD protecting a number of outgoing circuits. And what can happen, for example, is maybe you're in the shower, you've got the lights on, you're in the shower, a circuit develops an earth leakage fault. Maybe it's a kettle or whatever downstairs in the kitchen that somebody's switched on. It trips the RCD, which is protecting a bank of outgoing circuits, and suddenly the lights go off in the shower and you're plunged into darkness. So really, you need to think about the split of the board and where you have your power circuits and your lighting circuits, and consider whether you are actually introducing a risk if say, for example, an RCD takes out a bank of circuits, some of which might be lights, for example.
Yeah, you've created a hazard by the design of the circuit there, don't you?
Exactly. Yeah.
I often refer this to the Peter Kay Phoenix Nights. The last thing you want to do is have your stair lift kind of switched off in mid-flight due to your the wife in the kitchen doing the ironing, and the iron go faulty and take out your RCD, and you've got some problems down the line. So
there we go. Fortunately, I live in a bungalow, so I shall never have that problem. So that, if you like, is a consideration, certainly when you're thinking about, is dual RCD the solution for you? It may be that pushes you towards high integ or even split load, or maybe up to, if you like, the complete solution, which may be the main switch and individual RCBOs.
I think there's a constraint as well these days on the size of the board. In a perfect world, I mean, we sell a lot more duplex consumer units than we ever have done, which is the double bank board, because people are looking for splitting those circuits up more and more, because they may be tending to stick with a high integrity type layout, which obviously the RCDs take up two modules, but I think that becomes a problem in a lot of installations, in that there's not enough room to get these consumer units in. So that's another factor, people need to consider. Whereas the main switch with RCBOs, or even the new AFDD product, each circuit takes up one module, so it keeps the board relatively compact as well.
Yeah, I mean, if maybe you're replacing an old rewirable fuse or maybe a Wilex standard range from 30, 40 years ago, then the consumer units were probably only 200 mil wide. So the number of outgoing circuits that you had were few and far between, and you might be constrained by space. We do a lot of Mantel skeleton units for London, for tower blocks and so on, where you reduce amount of space. You've got to fit the consumer unit within that limited amount of space, width, height, depth. So that can point you or push you down a certain solution route, where you just can't afford to have RCDs protecting outgoing MCBs because you just haven't physically got the space.
I think there's a couple of things to always consider with an installation. There's the installation itself, which is what we've just been talking about. Is the board the right size? Is it going to do its job? And then there's also the consideration of how that's going to be used once it's installed. And we tend to find that the likes of a lot of local authorities are considering, if you've got a high integrity or a dual RCD board or even a split load, if one of those breakers switch off and the tenant actually rings in their helpline for a bit of guidance, my lights have gone off or all of my power's gone off, it's a lot more of a complicated conversation for that helpline person to advise the customer how to reset that device.
Exactly.
If they even want to kind of get to touch the consumer unit, a lot of people don't want to do that. So, there's a couple of things there, the consideration. If it is an RCBO and it's only that one circuit, it might be a case for we'll send somebody out tomorrow. We don't need to get somebody out on an emergency call out. So again, it's about the practicality of using the consumer unit after it's installed. And I would say that there's a fair chunk of the bespoke boards, I know you mentioned that we do for a lot of local authorities, that are main switch with RCBO, because although it's perhaps a more expensive way up front to do the installation, in terms of maintaining that and customer use, it pays dividends along the lines because there's less on costs, if you like, with that unit.
Yeah, certainly the main switchboard with RCBOs is a very common choice of a landlord. As you say, it's a little bit more expensive, but they just don't want the hassle of having to send an electrician round to reset an RCD that's been tripped by a faulty kettle.
Yeah.
And has took out all the power. So exactly as you say, there are justifications and reasons why you may go for a higher specification board over a lower one, because of the long-term cost saving that it can give you.
One of the comments I've had from electricians in terms of once they've installed it, obviously you've got to test the product. Great thing about the RCBOs that we use in the board, the single pole and switch neutral. So it's a breeze to test them. You just knock them off and they're disconnected, and you can 500 volt test them from the outgoing terminals, and you don't need to disconnect them, or flying leads don't need to be disconnected. So, there are some benefits of doing that as well. Yeah,
so that's a saving during the installation time. During the actual installation that the electrician can benefit from.
The other thing that one of the other things that we've seen quite in the public arena at the minute is surge protection. In consumer units, although surge protection has been around within our range for quite a while, it maybe over the last 2 to 3 years, it's really started to become a mainstay in the consumer units that we sell and that we manufacture, both as a standard product, that you can buy off the shelf with a surge arrestor built in, or we do an awful lot of bespoke boards where they're built up for customers and they're pre-wired for when they get on site.
I think, as you mentioned earlier, we're seeing a massive increase in the number of standard boards that we're supplying, which have got SPDs already fitted. It just makes it so much easier. It's already pre-wired. You get your board and you just fit it on the wall. And that's great when you're doing a consumer unit change or a new install. It's fairly straightforward. It's a little bit more of a challenge when you've got an existing installation. Obviously, there are different generations and designs that we've seen over the years, over the last decades. So, you have to sometimes think about how an SPD would fit within those existing boards. Some will fit, sometimes they won't. We also do separate enclosures with an REC switch, isolation switch, and an SPD fitted into them. And you can wire that in front of the consumer unit. And we find that that's a very good solution when you've got an existing installation that you're looking to upgrade cost effectively with an SPD.
I think the reason why we're selling this a lot more, there's a lot more installs going on with surge, is that although the regulations have always been there, again with it kind of being in the public arena more, it's we do a risk assessment. If we don't do a risk assessment on a domestic installation, then we need to fit a surge arrestor, and it's almost as black and white, which is not always the case with the wiring regulations, shall we say, but in terms of domestic surge, it's kind of you fit it or you don't, and this is the criteria.
Yeah, and I think the other thing is, I mean, obviously people talk about lightning strikes, it's probably more so than they do about transient surges. I think there are, in a typical house today, we have a lot of electronic equipment, and if there is a switching incident somewhere on your network local to you, your property could see a surge, and it could damage the electronic equipment. So it's certainly worth investing in SPDs as much from that side of things as it is from the possibility of a lightning strike.
Well, I think some of the time when a set of regulations come out, the first thing some people do is look at ways of getting around those regulations, unfortunately. And one of the things that often got quoted to me was the exception, which we've got on screen for single dwellings where the total value of the installation and the equipment doesn't justify surge protection. And I must admit, I kind of struggle if you just think about, where you are at the minute, maybe even the room or your home that you sat in, what's plugged in to your installation at the moment. And I'd suggest in most properties we've got a TV, maybe a DVD player. There's maybe a PlayStation in there, an electric boiler, with a printed circuit board in there, and just across those items, you've already exceeded over £1,000 just in those items alone, and that's the majority of those are probably in one room in your property. So, I think the reality of fitting surge or not fitting surge based on the value of the installation that we're protecting is probably a non-starter in most cases. And I think that's why we are starting to see surge become the way forward. It's just becoming a standard fit for the majority of people.
Very much so. So probably an area that's been talked about quite a lot with the 18th edition is the recommendation for arc fault detection devices, AFDDs. So that's come into the 18th edition. And I mean, the bottom line is that this is a technology that might be new to the UK, but it's certainly not a technology that's unique to the world. It's been in the States and Australia and other European countries for many years, certainly over 15 years in the States. So it's a well-proven technology that will protect against arc faults, which can manifest within an installation and can lead to fires. And obviously the consequences of a fire in a domestic residential property is damage to the property and worst case, loss of life. So AFDDs are very much closing that sort of that gap that has existed with existing circuit protection devices.
I think you're right. The difference is what does an AFDD do differently than an MCB or an RCBO? And an MCB will protect you from overcurrent. An RCBO will protect you. Sorry, an RCD will protect you from earth leakage, and an RCBO will do a combination of the two things. But what it won't do, and what it's not designed to do, is see that arc fault which can generate heat. And that heat that's been generated could then lead to a fire. So it's not that the MCB or the RCBO doesn't work in that situation. It's not designed to see that. And the way the AFDD works, effectively you're buying a microprocessor. You're no longer buying, if you take an MCB as being a mechanical device, then we've really moved on into the 21st century, if you like, with the AFDD. Technology moves on. We're certainly not sat here supplying rewirable fuses anymore. So the market moves on, technology moves on, and this is for safety, really. We're already seeing AFDDs being embraced again. Generally, it's the local authorities that will start to get the ball rolling on the technology coming into play, but we're already seeing AFDDs become part of our business, and particularly with it being a single module AFDD, again it's a compact device.
Exactly. I mean, it's the same physical size as our MCB and our RCBO, and our particular AFDDs are married up with an RCBO. So in a single MCB size device, you have got overcurrent, short circuit, and arc fault protection. So it's quite staggering what we've managed to fit within one small 18mm wide unit.
Mm. It's a concern for me and you, Dave, because I don't really know where we're going to go from here to make it any better.
I'm not sure we can make it any smaller, that's for sure.
A couple of the questions we get asked about AFDDs. Do they work on ring mains? Do they work on low load circuits? And just maybe to elaborate on that a little bit. Do they work on ring mains? Yes, is the answer. In reality, an arc fault occurring on a ring main on a serial arc fault, because what an AFDD will do, it'll detect a serial arc fault and it'll also detect a parallel arc fault. And the difference being a serial arc fault is, let's say, a loose connection in the live conductor. And what would happen in terms of a ring main circuit, if we had a loose connection in the live conductor, then the path of least resistance, the current wouldn't flow across that fault. The current would actually flow through the other leg of the ring main. So you wouldn't get arcing, you wouldn't get serial arcing occurring on a ring main. So that's where the AFDD wouldn't operate, because it wouldn't see it, because that arc fault wouldn't occur. But what can occur on a ring main circuit is a parallel arc fault. So if you've got cables maybe trapped underneath floorboards, which is creating a parallel arc fault between the phase and the neutral conductor, then that would happen on a radial circuit, and it would also happen on a ring main circuit. And that's where the AFDD would see that, and it would protect parallel arc faults on a ring main. So hopefully that's explained that, yes, AFDDs do work on ring main circuits, but it depends on the type of arc fault that's happening.
Yeah, no, I think the key thing is with serial arcs is that they do exist when you start plugging in appliances or extension cords into a ring main. So you're plugging into a socket as part of a ring main. You've then created effectively a single. I've got my words in.
You created a radial circuit, if you like.
Yeah, you've created a radial circuit, and then in that situation, then that conductor could be damaged, and in that situation you can have a serial arc, and I think when you look at a common or modern house these days, is we plug in so many items, whether it's electrical appliances, whether it's lighting, whether it's iPads, iPhones, and goodness knows all sorts of other electronic equipment that we plug in. You have a lot of potential for cord sets and the like to be damaged, and for a serial arc to occur. And the consequences are, if you get a serial arc and you haven't got AFDD protection, then that could manifest itself into a fire, and then obviously the damage to the property and the potential loss of life. So an arc fault detection device will protect you, will protect those vulnerable cord sets and the like, which tend to trail behind furniture and under furniture and under legs, etc., and are susceptible to damage.
I think that's probably one of the drivers for local authorities now selecting AFDDs, because at the installation stage, that's within the control of the contractor. It's within the control of the local authority to go and do their cyclic testing, etc. And you can look at that installation and you can say, yes, it's safe. The bit that you'll then lose control over is actually what's plugged into those socket outlets. So you could have a really safe fixed installation, if you like, and then somebody, we see all these scare stories, in witch magazines and the likes about, cheap chargers that you can buy for a couple of quid off the internet, leave them plugged in overnight, charging up your phone, and they're not really the right devices to charge up your iPhones, etc. And that's contributed to a number of fires. So this is where the AFDD, if you like, extends beyond the fixed installation to a certain extent, and gives you a greater level of protection. So I think that's fundamentally where some of the local authorities are going, to say, actually, if we can go a little bit further than the installation, if somebody does plug something in that maybe that cord set, as you say, gets trapped underneath a desk or gets rolled over, or often you might see a cable going through a doorway it's always being chafed as the door opens and closes. The AFDD, in terms of protecting that cable, that's where it'll come into its own.
On the question of testing, I mean, because we've got a microprocessor, then the device itself tests every 15 hours. So it goes through its own cycle of testing to make sure that the arc fault processor is working correctly. So it's a very clever piece of electronics, and obviously that gives you that peace of mind that it's working, 24/7.
I think, speaking as a spark, if you've gone back to a property and your AFDD's tripped off, particularly with our device, it actually indicates if it's tripped as a result of an AFDD, an arc fault, or it's tripped because it's the RCBO element that's tripped. So you've actually got some visual indication there of where do I start fault finding. So I think that's a good thing. I don't think there's any other device on the market that when you go to it, it actually says, yes, it's tripped off, it's in the off position, and it's tripped because it's an earth leakage, or it's tripped because it's an arc fault that I'm looking for, because they're two very different things to go hunting for in an electrical installation. So I think that's going to give us a bit of benefit as well.
Yeah, and the product itself, as we said, it comprises an RCBO element as well as the arc fault. So you've got 6 to 40 amp B and C curve, and they're all Type A RCD technology. So you've got the complete solution there. You've also got the 2-pole switching, as we mentioned, and again, testing of the individual circuits is straightforward and very quick to do, and obviously saves time for the electrician on site.
I remember when the RCDs were kind of launched, and then RCBOs, and again, we were always concerned about nuisance tripping. So if we go down the route of all AFDD / RCBOs, are we going to be in a position for a lot of nuisance tripping? But if the AFDD won't be nuisance tripping, but if it does show you that is an arc fault, it's tripped for a reason. People have asked us about low load circuits and high load circuits, and we've seen various videos on YouTube where people are trying to recreate an arc and trying to get an AFDD device to trip by maybe touching some contacts together, but that not necessarily. That's the arc fault that's going to cause you an issue. Part of the AFDD and part of the microprocessors is to understand the circuit. So there's a lot of devices out there, hoovers, electric drills, etc., switching on your light switch. All of these things generate arcs, and that's the way the installation's been for years. But the trick is to differentiate between what is, if you like, a friendly arc, a light switch switching on, or what is a dangerous arc. So where we see that some of those videos where we're trying to put two pieces of cable together and creating an arc, yes, we're seeing a spark, but that's in free air. It's not generating a great deal of heat, and is effectively a switching arc. When the arcs start to become dangerous, and when the AFDD starts to detect that, is when the arc starts to become consistent. So if you imagine that's maybe a damaged cable underneath the floorboard, then what will happen is the cable itself will start to show a carbon deposit, and it's the actual carbon tracking. It's when the supply actually uses the carbon track rather than the conductor itself to pass the load of the electricity. That's where things start to heat up. So it might be short term, it might be some sparking that could occur. That's not going to create a dangerous situation, but given time and that carbon building up around that break in the cable, that's what then generates the heat. That's what can ignite the surrounding, insulation once it dries out, or any other materials that cable comes into contact, and that's where that particular fault becomes dangerous. So there's a lot of technology crammed into that little box, shall we say, and that's part of the AFDD is obviously to trip in the event of a true fault, but we don't want it to trip every time we turn a light switch on and off or plug the Hoover in.
Very much so. So the other area that we've touched on is custom build. As a business, we manufacture and we design and manufacture in the UK. So we have the ability to bespoke make enclosures of different sizes. For example, we touched on meter cabinets earlier. Sort of things that fit within mantel units in risers, in tower blocks and the like. So we've manufactured a whole range of standard units, but we can also bespoke manufacture solutions as well. We do an awful lot of consumer units which are fully populated with MCBs, RCDs, AFDDs to suit specific customer requirements. And we can also create upgrade kits for old and existing installations to upgrade them.
I think as a business, we've certainly got one eye on the future, and we've always had one eye on the past as well, haven't we? Retrofit is a big part of what we do as well. And again, from a customer point of view, you want some longevity in your product. You want to know that the product's going to be around for a long time, and you can service it should you need to do that. Sorry, David, go on.
I was going to say, I mean, I think, with Crabtree and Wilex brands in particular, they've both been around over 100 years. So, I think that longevity that you talked about, we've always been involved in circuit protection and very much a leader in the technology and the product solutions. And I think that gives a lot of reassurance to installers and specifiers and end users that, we've been around a long time and we'll be around a long time in the future.
I think even more so now. People may not be aware, but Electrium as a business is actually part of Siemens, and Siemens being a global manufacturer. So a lot of the development and the technology that we're moving forward as either, as you mentioned earlier, Dave, with the AFDD, it's long established technology that's been used, for a number of years. So it's stuff that's tried and tested, and with that development behind us as well, I can only see us developing even better products as we go further and as the technology requires it.
Very much so.
I mean, in summary, where do we think the consumer unit's going? That's we live it and breathe it every day, as exciting as it tends to be. But
well, I think if you apply the regulations explicitly, then I think it does nudge people towards the use of RCBOs more and more so. And ultimately that should be a main switchboard with every individual circuit protected by an RCBO. You can utilise high integ and you can utilise split load, but there's always a little bit of a trade-off, I guess, if you're using those solutions. So ultimately, we would always steer people towards the main switchboard. We've had the 18th edition for a little while now. Amendment 1's out, addressing EV. We've got Amendment 2, which is due to come out April 2022. We've currently got AFDDs recommended. I guess there's a fair chance that they might be mandated come April 2022. So certainly I think if you're going to invest in AFDD technology, then that's incorporating RCBOs, and then that's again pushing you towards a main switchboard. You know, you really should be putting an SPD at the front of it, or certainly ordering the board with the SPD at the front of it pre-installed, and that really gives you your ultimate solution.
I think from both of the ranges, both Wilex and Crabtree, it is a range, and it's probably the biggest range available in the UK. So there are products there for different levels in the market, and there's products there to give you different solutions. So hopefully we've got a product that suits the installation that you're doing it tomorrow and the next day and the day after. Hopefully, you know, some of this may have been of interest. Hopefully we've cleared a few myths, particularly around AFDDs. But if you'd like to ask us any questions, please drop us an email